Example 2 has a relationship in words. So it says here that the total number of pies and cakes that can be produced by a bakery in one day is 100. So write an expression for the possible numbers of pies and cakes that make the graph. Okay, so I'm going to make a let statement here. I'm going to let x equals. Now, x is usually my independent variable. So does the 100 depend on pies or does it depend on cakes? Now, again, this is one where it's not really clear. So we can arbitrarily say that, well, let's let x equals pies and y equals cakes, the number of cakes. Okay. So we're saying that the cakes is dependent on pies, but really it could have been the other way around. But for convenience sake, we're just going to say the pies is our x and our cakes is our y. So we need to then come up with a relationship. Okay? And what I know this relationship is saying is that together they add up to 100. So I'm just going to say x plus y equals 100. And I can make my table of values based on this. I could have done it without it. I could have just, may start making some numbers, 50 and 50, etc. But I'm going to start with my equation. Again, I've made my y my output, so I'm going to rearrange my y so that it's a little bit easier to see the output like that. Okay, we can write it like that, or we can write it as 100 minus x. And so if I have 0 pies, how many cakes can I make? Well, I'd have to make 100 cakes and pies, so I need to make 100 cakes. If I make 20 pies, there's 80 cakes. And again, based on the word relationship, I can come up with this, but based on my equation as well, 100 minus 20 is 80. We can make 50 and 50. We can make 80 and 20. And we can make 100 pies, but then that means we make no cakes. Now in this case, it doesn't make sense to make negative pies or more than 100 pies. Okay, so our domain is restricted here. So we're really just going to end up graphing in quadrant 1. And I'm just going to graph 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I'm just going to say that's my 100, and that's my pies along this axis. And this is cakes along this axis. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so this is going to be 100 pies here. That's going to be 100 cakes there. Okay, and if I make 100 pies, I make 0 cakes. If I make 100 cakes, I make 0 pies. So that's where it would look like. And I could start plugging my other values. 20 for pies, 80 for cakes, somewhere around there. 50 and 50, so 50 and 50 is right about there. 80 and 20 is right about here. And again, notice that we get a straight line pattern. Again, that's what we're looking for. We're looking for the pattern. Now this one I'm not going to extend beyond the first and last points, because in this problem, the context is that, well, we can't really make negative cakes and negative pies. So there's my relationship. It has a restricted domain. Okay, so my domain, I'm going to say, is between 0 and 100. And in this case, we can say that x is just our integers, and the range is going to be from 0 to 100 as well. And y is going to be integers. So I put real there, but really we can write down it's integers, unless you think we can make part cakes and part cakes and part pies. Okay, so that funny looking Z is the symbol for integers. We can use that, or it's maybe easier to use the I for integers. Okay, so this would be discrete. So although I've drawn in a line, it is a discrete problem if we just kind of think of not fractions of or part cakes and part pies.